In this problem, we need to graph the graph that will result from the function we're given. Hopefully you can notice that the second power there will give us a parabola. And hopefully you notice that the negative out front of the quantity means our parabola will open down. Next, we should figure out where the vertex is. That's going to be the top of this downward opening parabola. The x-coordinate comes from setting the squared quantity equal to 0. If x plus 1 equals 0, means x has to be negative 1. That will be the x-coordinate of our vertex. The y-coordinate will come from the constant term all by itself. In this case, that's negative 3. So when you put it all together, you get a vertex at negative 1, negative 3. I'll plot that here. Next, we know this is going to open down, so every other point should be below this vertex that we've already plotted. One way to do this, if you prefer, you can certainly make an XY table and put that negative 1, negative 3 in the middle of the table and just plug in a couple of x values on either side and see what you get for each y value. That would graph the rest of this graph. Otherwise, if you're into shortcuts, you can say, well, if I'm working off the vertex, if I go 1 to the right, I should be going 1 squared down, which would be 1 unit. And whatever you do on the right of the vertex, you'll also have to do on the left of the vertex. Going back to the vertex to plot another couple points, if you go 2 to the right, 2 in the x direction would give you 2 squared in the y direction, because we're squaring all the x values in a parabola. So 2 to the right would give you 2 squared down, which is 4. 1, 2, 3, 4. And then you get the same thing going the other way. 2 to the left would give you 2 squared down. 1, 2, 3, 4. And we're about to run out of paper, so I will go ahead and draw in the smooth curve. You would get these same y values by plugging the x-coordinates into the function. You should get a negative 7 here and a negative 7 here as well. So either way you graph it, it should look the same.